Today our topic irrational numbers. What is irrational number? So before you know the irrational number, you need to know what is a rational number. For example, if you want to know the light, darkness, so the opposite of darkness. So what type of relation is there, darkness and light? Okay. So this two are in a classroom. If you take boys and girls, so if you know the who is a boy, you cannot say who is not boy. The means is a girl. Okay. Here, rational numbers and irrational numbers between also there is a such relation. The means which is irrational number is surely not a rational number. Which is rational number, surely it is not the irrational number. So, if you want to know the irrational number, you need to know what is a rational number. So, we know what is the rational number. We will see once. So, we know the numbers, integers. Okay, after integers, fractions. So, the number which is in the P by Q form, where P comma Q or belongs to integers. So this type of numbers are called the rational numbers. Rational number generally it is denoted by Q. So this is a form of number, P by Q form, like a fraction. But numerator and denominator both should be integers. And Q means the denominator should not equal to 0. Denominator should not equal to 0. That means numerator may be 0. Okay. So this is what is the rational number. What about the irrational number? So which is not rational? Which is not rational? Which is not rational number? Which is not rational number is irrational number. So this is the meaning of irrational number. Which is not rational number is irrational number. Basically we see the what are the irrational number, how we will write the numbers. We know the integers. So 0, right side 1, 2, 3 and left side -1. It's negatives. -1, so -2 and so on. These are the integers. You can write -3 and so on. Okay, many infinitive. By using these numbers, if you write any, these all numbers, P by Q form. So they are the rational numbers. I give some numbers. For example, I'm taking some numbers. Numbers. The numbers are, you can see. So -3, 0, 4. No doubt it are the integers. Now if you want to see these numbers in the P by Q form, you can take these numbers by 1, any number. So these are purely P by Q form, denominator not equal to 0 and both are the numerator and denominator integers. So these are rational numbers. Now if I take some numbers 2 by 3, maybe 1 by 3, like, okay, these numbers, maybe 8 by 5, these are. So these all numbers are, you can see integers only, you take minus also. These all are the rational numbers. So all fractions is a rational numbers which are from the numerator and denominator, the integers. Now, so these numbers, these are also integers. Beginning I show to you, all integers are the rational numbers. Now I am going to decimal numbers. It is 0.257, you can see this type of number, or 4.223333475, like maybe. Okay, 247.004. So these are after decimal number, they have decimal digit 3. Here 6 are there, here 3 are there. So this type of the decimal number which is the finite digits, the minutes, that means decimal digits are countable. There is a 3 digits, 4 digits. This type of numbers are surely the rational numbers. I am saying that finite digits. So if any decimal number contain the infinite digit, what we can say? So there are the two types. One is 0.33333 and so on. Okay. So this 5.272727, we are repeating. These numbers we will write generally 0.3 comma recurring. So this is, and here after this there are dot dot dot, many numbers will come like this. This will write 5.27 bar for the 27. So this type of numbers. So these are the infinitive digits are there. So all finite digit numbers are no doubt rational numbers. This also rational number is a rational number. This is also rational number. You know this is a 0.13333. It is nothing but 1 by 3. When you divide this one, you will get this one. So 1 by 3 already we written as a rational number. When you convert into it, it will get a decimal number like this. So all decimal numbers, finite digits are the rational numbers. Infinite repeated digits. What about we are learning rational numbers instead of learning the irrational numbers. What about irrational number? So in this type of decimal numbers, if you find the number 4.237562858 like this, you can see here 23756 is came 2 again, but 8 is not repeating up. Non-repeated decimal infinitive decimal numbers are the irrational numbers. It is a irrational number. So is a irrational number. Decimal numbers which are the infinitive digits with non-repetition, that is a irrational number. Infinitive digits with repetition is called a rational number, and non-repeat numbers are the irrational numbers. So these are the decimal type irrational number. Clear? Now any fractional type irrational numbers are there? Yes. So this is a fraction type, like 1 by denominator root 3, root 2 by 5, root 3 by 4 root 2, you can see. So only denominator you are finding root number. You cannot simplify this one. You cannot simplify. Root 3. So there is no square root for root 3. So this type of numbers, root 2. So these are irrational numbers. Okay. So simply you can take root 2, root 3, root 7, not only root 7, root 8 also. Square root of root 8 is not there. But root 4 is a, so we know that root 4 value it is equal to 2. Positive number if I take. So root 4 value is 2 is a rational number. This is a rational. So don't think all the root numbers are the irrationals. So which values does not find. The means when you simplify, we cannot get a integer, their value. So that are the irrational numbers. So which number we can simplify, you get the integer, and the integer is a solution or answer for this. So this type of numbers are the rational numbers. Root 16 is a rational number. So these are the irrational number. So fraction type of number means the number in the numerator or denominator should have the root number. This also no, you can write p by q form. But p by q form is their fraction form. But numerator and denominator are not integers. Okay. So these are the irrational numbers. Now we know that pi is a irrational number. Pi. Actually this is a special case. Pi is a irrational number. So in geometry we use the pi value 22 by 7 actually. So it is irrational number, but that is not exact value of the pi, it is approximate value. So pi is a irrational number. Clear? So thank you.